Hi class, we're going to take a look at the second method for simplifying this complex rational. In the second method, instead of having to take a look at finding a common denominator for the numerator and a common denominator for the denominator, and then creating one fraction in the numerator and one in the denominator, all we need to do is take a look at the entire problem and find a common denominator for the entire thing. And notice that we have an x minus 3 here. So you want to think of that as being grouped all as 1. And over here, the 4 has a 1 underneath it, which we don't need to worry about, and so does the 3. But right here, on this one here, notice that that is not factored. In order to find the common denominator for the entire thing, we should factor that. And this is a difference of squares. So it's going to factor into x plus 3, x minus 3. Now, if we notice and we compare this denominator here to that denominator here, if we want a common denominator for the entire expression here, it's going to be an x plus 3 and an x minus 3. Once we've determined that common denominator for the entire problem, then the next step would be to go ahead and multiply the numerator by that common denominator of x plus 3 times x minus 3 and multiply the denominator by it, which is something that we've done when we found equivalent fractions before. Now, when you do this, be sure to not skip any steps so that you don't make any mistakes. It's very easy to make a mistake on this particular part of the problem. You're going to distribute this over to the first fraction here, and it's going to give you x plus 3 times x minus 3 times the 5 over x minus 3. Then you're also going to distribute it here. So you're going to have 4 times your x plus 3 times your x minus 3. It doesn't matter which order these are in as long as they're all there. And now go ahead and distribute this to the numerator. Now, for the denominator, we're going to distribute it over to here. That's going to give us x plus 3 times x minus 3, which is going to be multiplied by 3. And I'm going to put that in front just like I did before over here. And we're going to subtract from that this multiplied by that. So that's going to be an x plus 3 times x minus 3 multiplied by the 2 over x plus 3, leaving this in factored form in the denominator, times x minus 3. Now we can go ahead and cancel anything that is possible to cancel. So if we go ahead and cancel here, these two will cancel. We're able to distribute our 5 and get 5x plus 15. And that takes us as far as we can go for that. And then over here, if we multiply this back out, notice that we're going to get an x squared minus 9, which we can do that and then distribute 4 across. And that gives us 4x squared minus 36. Now in your denominator, these cancel here, leaving you with the 2. So in the denominator, if we go ahead and multiply these, notice that we're getting x squared minus 9. And then we can distribute this 3 to get a 3x squared minus 27. And then we have our subtraction here of this 2 that's left in the second part. Now, if we simplify this, The numerator comes out to 4x squared plus 5x minus 21, because 15 minus 36 will be a negative 21. And in the denominator, when we simplify that, we get 3x squared minus 29. And this here would be fine for your simplified form. And you might be saying that that's not exactly the same answer we got in the video for method 1, which had the same problem. In method 1, our numerator was 4x squared minus 7 times x plus 3. And, excuse me, not 4x squared, just 4x. And when you simplify this and multiply it out, watch what happens. This 4x times x becomes 4x squared. These 4x times 3 becomes a 12x. The negative 7 times x becomes a negative 7x. And negative 7 times 3 becomes negative 21. The middle terms here will combine into the 5x, which gives us the same thing that we have in the numerator right here. So even though this looks different, it is actually the same solution that we got in the method 1 video. So for method 2, just a reminder of what you do for that is you take a look at the entire problem, find the common denominator for the entire problem, multiply your numerator by it, multiply your denominator by it, and that will clear out the fractions in the numerator and denominator, which brings you straight to your solution here. And it's fine to leave this in this form or to factor the numerator into the same solution that we had when we did the method 1.